In this video, we're going to talk about section 2.2 and introduction to deductive reasoning. So we've actually already talked about inductive reasoning, and we did a whole thing on sets and Venn diagrams, really to be able to talk about deductive reasoning. Okay, so we kind of did that in preparation to talk about this. So let's refresh our memory about inductive reasoning really quick. So inductive reasoning, we use a pattern to make a prediction or conclusion, really for the purpose of conclusion for right now. Let me give an example. Like, let's say I write 2, 4, 6, 8, ... From here, you could probably conclude that the next number is 10 based on that pattern, and you would be correct. All right. But sometimes patterns aren't so obvious. So like if I give you this pattern, especially based on having just talked about the even numbers, you might be inclined to say, oh, maybe those are the odd numbers. So perhaps the next number is 5. And I'm like, nope, I'll give you another one. So I'm like, okay, so how about I give you 6 now, ... And you're like, huh, okay. Well, kind of noticing the pattern here. These two, we added 2, but these two, we added 3. So maybe the next one we add 4. So I'm like, is the next one 10? And I'm like, yay, you're amazing. You figured it out. But it was kind of more difficult because sometimes the patterns aren't so obvious given enough information, if we're not given enough information. Another example of inductive reasoning, and this is more using something like we might do in our everyday life. Okay. Let's say Mary is late, or let's say has been late. Mary has been late to every class so far. Obviously, this is a class that requires attendance. I might now conclude at this point that Mary is going to be late to the next class. Okay. Now, is that a good conclusion? Well, it depends. How far into the term are we? Are we talking about we're halfway through the term and Mary has been late to every single class? Then yeah, I'd probably feel pretty comfortable saying Mary's going to be late to the next class. But if we're only a couple weeks in and people are kind of getting used to their schedules, I don't know if I feel as comfortable making this conclusion. Is it possible Mary's going to be on time? Yeah, that things could change for Mary that makes it so that she can show up on time. Okay. But we use inductive reasoning in our life all the time. It is, however, not as reliable. Deductive reasoning, though, is far more reliable. So let me go ahead and define it. And then we will try to look at some arguments using deductive reasoning. So deductive reasoning uses given statements to make conclusions. The given statements are called premises. That's supposed to be an A. Are called premises. So we're given these premises, and the idea is we try to make conclusion based off those. And that's how deductive arguments work. And is it possible we will always be able to make a conclusion? No, it may not be. And that would be then we would say we can't make any sort of judgment or statement or conclusion. But it allows us to look at arguments in a more systematic way that helps us to judge whether or not they're valid or invalid. All right, let me give an example of a deductive argument. Let's say we are given the following premises. The sum of two numbers is 243. One number is 56. Conclusion, the other number is 187. So this is a deductive argument. It's taking those two premises and making its conclusion. And what's nice is we can verify that the conclusion makes sense. So if we know that two numbers is 243, I'm going to take 243 and on my calculator, I'm going to go ahead and subtract 56 and I'm going to verify that it works. Lo and behold, I do get 187. All right. So this is a valid argument. Okay. Those three little dots that I just drew right here, that is a symbol used often in math and science to mean conclusion. Okay. So I'm making the conclusion that this is a valid deductive argument, that the conclusion follows from the two premises. All right. Okay, so what we want to do is we want to come up with structure that helps us with this, not just looking at, kind of logical statements like this, but as they're, expanding out, we want to have a way of looking at it. So here's where we're going to bring in Venn diagrams. So we're going to use Venn diagrams in deductive reasoning. All right. So let's do an example. So I'm going to give you my premises. All humpback whales. I'm sorry. All humpbacks are whales. There we go. All whales are mammals. Okay, so for conclusion, all humpbacks are mammals. All right. Now, that does seem like a good valid argument, but here's how we can prove it. So we are going to create a Venn diagram, and I'm going to go ahead and just stick with blue for saving a little time here on the video. And I'm going to start with the first premise. The first premise says all humpbacks are whales. Okay, so here's what I have. I have the idea that if anything is a humpback, it's automatically a whale. And that what we have, oops, sorry, I'm going to make this a little bit smaller. What we have is this category of whales here, and this category of humpbacks that are in that. All right. So I had to split the word humpback up. And there we go. So humpbacks are all whales, period. So all of them, therefore I drew a subset diagram here for the Venn diagram. But when I look at premise 2, it's another subset. It's saying all whales are mammals. So what I can kind of do is take the second premise and I can see that I have a bigger category outside of the whales, which we will call mammals. So does it make sense then to conclude that all humpbacks are mammals? Well, yes, humpbacks are now considered a subset of mammals based on this picture. So this would be a valid conclusion. What we're seeing is that if something is in here, it automatically is in the category of mammals as well. So you use like a little dot to indicate like where our little person is in this scenario. All right. Okay, let's try another example. let's say our premises are all custom officials are government employees. Some college grads are custom officials. I should say college graduates are custom officials. I'll say customs officials. I should probably say that up there, customs. So we're referring to those who check people into the country or at the airports, right? So conclusion. Some college grads or graduates are government employees. Okay. Now, we're going to draw this out. And I actually have a bit of a different opinion than what the book kind of states. Okay. But we'll talk about it. We'll talk about what the book says. Okay. So here, let's start with the first premise. All customs officials are government employees. Okay. So here, let me give myself a little space. Draw my box. All right. So CO is customs officials. Oops. Officials. GE is government employees. Oops, there should be another E. Eventually it'll erase. And then CG will be college grad. Okay, cool. There we go. All right, so what we have then is from the first statement, all customs officials are government employees. So I'm going to go ahead and do a subset there. So here's our category of customs officials within the category of government employees. Okay, now some college grads are customs officials. Okay, so what that means is that word some to me sounds like we want to make like an overlapping set with customs officials. Okay. And the way they kind of drew this is they rather than do a circle, they did like kind of an oblong shape in the book to represent it. So these would be college grads. Oops. And the information we're told is that some of them are college grads and customs officials. So the conclusion to me seems valid because it sounds to me like you're saying then there are some college graduates that are custom or government employees. And to me, that seems true because clearly we've indicated, oh, and they actually use the blue. Sorry. They indicated that there's this little group right here in the middle that are both that are college grads and therefore they're within the government employee category. Now, the book made a point of saying, well, there are college grads, there may not be anybody in these groups, right? It's possible that there's nobody in those groups. We don't know. And their argument was maybe it's not that some college grads are government employees, but maybe it's all college grads are government employees based on the information they're saying. So the book kind of says they feel like this is a bad conclusion. Okay. They kind of say that we just don't have enough information. I'm going to write down not enough info. And their argument is the word some. They're saying we can't say some because we don't know if it really is some. Maybe it's all. Maybe it's possible that all college graduates are government employees. And therefore, we can't make that conclusion. I kind of feel that to say some college graduates are government employees doesn't necessarily violate all college graduates are government employees, but the book does feel that way. Okay, so I slightly, I'm not sure I feel as comfortable with that conclusion, but I understand why they made that conclusion. So we're not going to call this argument invalid. What we're going to just say is there's not enough information. Okay, that's why I wrote not enough info. That's my conclusion. So I'm not going to say invalid, just not enough information. All right, next. Premises. Oh, spelled that wrong. Premises, there we go. Some members of the Appropriations Committee are Republicans. Second premise, some Republicans are on the Ethics Committee. So conclusion, some members of the Appropriations Committee are on the Ethics Committee. Oops. All right. Okay, so let's write this. So I'm noticing the first two premises are using the word some. So it's kind of implying an overlap when we're drawing our Venn diagram, okay? So I'm going to, again, give some labels here. So we'll have Appropriations Committee, all right? And then we'll have the Ethics Committee. And then for Republicans, I'll just use REP, okay, for Republicans. All right, so those are my labels I'll use. So first premise, some members of the Appropriation Committee are Republicans. So we have an overlap. The second one, some Republicans are on the Ethics Committee. Now, I could choose to draw the Ethics Committee intersecting both of these, but based on this information, I could draw the Ethics Committee right here as its own separate circle from the Appropriations Committee and allow them to be separate. And I haven't violated what I've been told. What I was told, actually here, I wanted to do it in green. Sorry. I was trying to do the second premises in green so I could see that. Oops. Okay. I apologize for that. Republicans. Okay. And then here, I'm going to do that. Ethics Committee in green. Okay. Now we have people here, but not necessarily overlapping. So because I can draw this in a way where all premises are satisfied, but it violates the conclusion, then it's a bad conclusion. Okay. So this conclusion is invalid. It's a bad argument. Based on that information, we don't know that. There's possibly far enough in Republicans that they don't have to both be on both committees, because that's what the implication is. The implication is that there's a member of the Republican Party who's on both committees. Is it possible? Yes. But based on this information, we cannot make that conclusion. That's an invalid argument. I can draw it in a way that it violates what they have said, but doesn't violate the premises. All right. In the next video, we're going to kind of take this a step further.